Hello, everybody. Welcome to our How to Do Research and Get Published webinar on data collection and analysis. We're excited to explore the role of data in research. Data is the foundation of research, and without high-quality data, findings may lack credibility. Today, we'll focus on data collection methods, ensuring quality, ethical considerations, analysis, and sharing. But before we do that, I want to introduce you to our team. Arpita Bhattacharya is a research integrity editor at Sage. She handles issues arising prior to and after publication and assists in developing processes for ethical publishing practices. Anami Kabir is a group marketing manager at Sage, where she manages the open access marketing communications team in the UK. Anami is adept in data-driven marketing through data harvesting, audience segmentation, customer-centric outreach, and more. Next, James Salvo teaches qualitative research in the College of Education at the University of Florida. He is an associate editor of Qualitative Inquiry, Cultural Studies and Critical Methodologies, an International Review of Qualitative Research, and an assistant editor of Qualitative Health Research, all journals with Sage. Next, Jessica Offenberger is a publishing editor on the STM Journal's editorial team. She manages a range of science and medicine journals, working with editors and societies to develop new strategies and problem solve. And last, I'm Sean Skarsbrick, a senior marketing manager on the author marketing team. My primary role is to support authors and reviewers as they move through the publishing and reviewing processes. Before we get started, I wanted to highlight James's work. You'll see the 4 journals that he works with at Sage. If you're interested in If you have a manuscript that might be a good fit for these journals, feel free to look at these as potential fits. And of course, if you're looking to review, this may be a good space for you as well. We will share the slides with everybody today, so you're able to go directly into these as well. For today's webinar, we have a Q&A session at the end, and you'll see the Q&A box on your screen. Throughout the call today, please send any questions you have for our panelists, and we'll address them at the end of the call. If you see a question you particularly like, feel free to upvote it, and we'll start with those at the end. And now to situate us, I'd like to focus on the typical author journey, moving from the early stages of securing funding and conducting research all the way through peer review and publication. As you know, today we'll talk about data collection and analysis, but we do encourage you to go back and watch other recordings of topics we've covered, including how to secure grant funding and the role of mentorship. And with that, I'm happy to pass it off to Arpita.
Thank you, Sean. So understanding data collection. Data collection is a systematic approach of gathering information. Accurate data is critical to making informed decision. There are 2 types of data, quantitative and qualitative. Quantitative data is numerical, while qualitative data provides descriptive insights. Both play vital roles in research. In regard to data, consider factors like sample size, methodology, and ethical implications. Could we move to the next one, Sean? There are many ways you can collect data. Surveys are a popular tool of gathering large-scale data. When creating a survey, ensure questions are clear and unbiased. Interviews are another good option to employ. Structured interviews follow a set format, while unstructured follow open-ended questions. In participant observation, researchers engage with subjects. In non-participant, they observe from a distance. Controlled experiments take place in a controlled environment, while field experiments happen in real-world settings. The method section is incredibly important to the paper, so it is a key area one should focus on. Next one, Sean. When it comes to looking at the methods and data analysis, there are a number of key items to focus on. The first is the study design. Make sure that there are no concerns with the way in which the study is being conducted. Is the study design common for the type of study being conducted? Are the experiments and methodology used common for the field or novel to the field? If they are novel to the field, there may be a need for additional explanation as to why the method was chosen. When ultimately working on your manuscript, is the material and method section descriptive enough so that the study could be reproduced? This includes items like procedure followed or a literature reference to the procedure, including critical steps that are unique to the study, such as dilatations of antibodies used, as well as catalog numbers or company names for the regions and equipments used. Are the statistical techniques relevant to the study? Are they the standard for that kind of study? Are the material and methods used for the study appropriate for the research question being addressed? This should all play into which method you are going to use to collect the data. With that, I'll pass on to Anami.
Thank you, Arpita, and hello, everyone. I'll be talking about ensuring quality data. So first of all, minimizing bias in data collection. Bias can distort findings, leading to inaccurate conclusions. And then there are strategies to minimize bias include using random sampling techniques, crafting neutral and well-balanced survey questions, training data collectors to remain objective and avoid leading questions, and implementing double anonymous study designs to prevent observer bias. Then we have enhancing validity and reliability. Validity ensures the study accurately measures what it intends to, while reliability ensures consistency over repeated measurements. So, ways to enhance both include standardizing procedures to ensure all participants experience the same conditions, using well-established and tested data collection instruments, conducting pilot studies to refine methods before full-scale research, and triangulating data by collecting from multiple sources to cross-verify findings. So there are best practices for accurate data collection. So to ensure high quality and accurate data collection, we can maintain clear documentation of methods and procedures, regularly check data for errors and inconsistencies, use technology such as automated data entry systems to reduce human errors. So keep detailed records of data sources and processing steps for transparency. So next slide, please. So I'll now be talking about random sampling techniques. So to ensure diverse and representative samples, we can use random sampling techniques. So using random sampling techniques means selecting a subset of individuals or data points from a larger population in a way that ensures every individual has an equal chance of being chosen. So this reduces selection bias and enhances the representativeness of the sample, leading to more generalizable research findings. So how to use random sampling techniques. So we have simple random sampling, which is assign a unique number to each individual in the population. Use a random number generator or lottery method to select participants. So for example, a researcher assigns numbers to 500 students and randomly selects 50 using a computer program. Then we have stratified random sampling, divide the population into subgroups like strata based on shared characteristics. So for example, age, gender, income level. Randomly select participants from each subgroup in proportion to their representation in the population. So for example, if a university has 60% undergraduate and 40% graduate students, the sample should maintain the same ratio. Then we have systematic random sampling. So list the entire population in a sequence, choose a random starting point, then select the nth individual. So for example, a researcher selects every fifth person on a class roster after picking a random starting point. We have cluster random sampling. Divide the population into clusters. So for example, schools, neighborhoods. Randomly select entire clusters instead of individuals. So for example, a researcher studying education selects 10 schools randomly instead of selecting individual students. And then finally, we have the multi-stage random sampling. Combine multiple random sampling methods. For example, first randomly select schools, that's cluster sampling, then randomly select students from those schools, that's simple random sampling. If you can go to the next slide, please. So I'll be talking about remaining objective and avoid leading questions. So training data collectors to remain objective and avoid leading questions is essential for gathering reliable, unbiased data. So here are some tips for training. First, Emphasize the importance of neutrality. Train data collectors to approach each interview or survey with an open mind and to avoid influencing the responses of participants. They should not show approval or disapproval during data collection. Explain that the goal is to capture the participants' true views, not to guide them towards a specific answer. Use clear and neutral language. So avoid leading language. Like ensure questions do not suggest a desired answer. For example, instead of asking, "How helpful did you find our customer service?" which assumes the service was helpful, ask, "How would you rate your experience with our customer service?" Avoid loaded questions. Don't ask questions that might make participants feel pressure to respond a certain way. For example, "Why do you think our service is so much better than others?" could lead to a biased response. Instead, ask, "How would you compare our service to others?" Teach active listening. Encourage data collectors to listen attentively without interrupting, which can influence the participants' response. They should be trained to ask follow-up questions that help clarify without leading or changing the focus of the conversation. And then be mindful of body language and tone to avoid unintentional cues that might direct participants towards a specific response. And then use open-ended questions. Whenever possible, encourage the use of open-ended questions that allow participants to answer in their own words. For example, instead of asking, "Do you agree that the new policy is better?" ask, "What is your opinion on the new policy?" So this reduces the risk of influencing the answer while gathering richer, more nuanced data. You can role play and have mock interviews. So run mock interviews or survey administrations where data collectors practice asking questions in a neutral way. Role playing helps them get feedback on their approach, tone, and wording. Create scenarios where data collectors can practice dealing with biased or leading responses and learn how to refocus the interview without pressuring the participant. You can review sample questions together, go over survey or interview questions as a team before the data collection process. This helps ensure that the language is neutral and free from any inadvertent bias. Discuss why certain questions might be leading and work together to reframe them objectively. Avoid confirmation bias. Teach data collectors to avoid the temptation to look for answers that confirm their expectations. They should be aware of their own biases and ensure they're gathering data based on the participant's perspective and not their own. Ensure consistency. Emphasize the importance of maintaining consistency in how questions are asked and how responses are recorded. Data collectors should stick to the script and avoid paraphrasing or rewording questions during interviews. And finally, encourage reflection and self-awareness and self-assessment. After data collection sessions, encourage data collectors to reflect on their own performance. Ask them to assess whether they might have unintentionally influenced responses and how they could improve in the future. So by incorporating these strategies into your training, you can help data collectors remain objective, avoid leading questions, and ensure the data you collect is reliable and unbiased. If we can go to the next slide. Thanks. So steps to implement a double anonymous study design. So first of all, masking the participants and researchers. Ensure participants do not know which group they're assigned to. For example, treatment versus control. Ensure the researchers interacting with participants do not know the assignments either. Using third-party randomization, assign groups using an independent team or a computer-generated randomization system. So for example, a clinical trial assigns patients to drug A or drug B via an automated system without researcher involvement. There's blinding during data collection. Ensure data collectors do not have access to key study information that could influence their observations. For example, in an interview study, interviewers do not know whether participants belong to a high risk or a low risk group. Using coded identifiers, replace personal or group identifiers with anonymous codes before sharing data with researchers. So, for example, researchers analyzing exam scores receive de-identified data without knowing which group the students belong to. Training researchers on bias prevention. Educate all team members on potential biases and the importance of maintaining the study's anonymity. Reinforce adherence to protocols that prevent accidental unblinding. Conducting blind data analysis, analysts should not know which group corresponds to which condition while processing the data. For example, data analysts work with data sets labeled Group X and Group Y without knowing which is the treatment group. Using placebos or sham interventions, this is for experimental studies. If applicable, provide a placebo or sham intervention that mimics the real intervention. For example, in a drug trial, participants receive either the actual drug or a placebo, and neither they nor the administering doctor knows which one. And then finally, implementing double-blind peer review. This is for qualitative research. If analyzing qualitative responses, anonymize transcripts so that reviewers do not know participant details. So, for example, a study on workplace culture removes job titles and company names before qualitative coding. So we can move on to Arpita, please.
Thanks, Anami. A little bit about ensuring strong protocols. So, importance of clear data collection protocols. Protocols provide consistency and improve data reliability. Training data collectors effectively. Proper training reduces errors and ensures standardized data collection. Conducting pilot studies for refinement. Pilot studies help identify issues before full-scale data collection begins. Could we move to the next one, Sean? Ethical considerations. Participants must be fully aware of the study's purpose before providing consent. Protect participant confidentiality. So also in line with the previous consent point, in line with this, one must ensure that we are, protecting participant confidentiality, ensure data security and compliance, ensure data is anonymized and stored securely to maintain privacy. Ensuring data security and compliance is important. Follow legal regulations and ethical guidelines to protect sensitive information. Could we move to the next one, Sean? So a little bit about data analysis. Basic steps in data analysis include cleaning, organizing, and analyzing and interpreting data. Common tools for data analysis includes Excel, SPSS, R, and Python. So choose the one that fits your research needs. Challenges include missing data and biases. Solutions include robust statistical techniques and data validation. Choosing the right data analysis tool depends on several factors, including the type of data you're working with, the complexity of analysis, and the level of your expertise and your research goals. Just for comparison, I'm going to talk a little bit about Excel, SPSS, R, and Python, just to help you select the best fit. Excel, it is best for basic data analysis, small data sets, and quick visualizations. Its strengths are that it has a user-friendly interface, good for descriptive statistics, mean, median, standard deviation. Built-in functions and pivot tables are there for data summarization, charting and visualization capabilities are there. Limitations, Excel is not suitable for large data sets or complex statistical analysis. Limited automation and reproducibility compared to programming languages. It is susceptible to human errors, manual entry issues. So choose Excel if you need a platform for simple statistical analysis, visualize data quickly, and work with small data sets in familiar spreadsheet environment. Statistical Package for Social Sciences, or SPSS. It is best for survey analysis, social science research, and structured data. Strengths: it has a easy-to-use graphic user interface for statistical tests. It's great for ANOVA, regression, factor analysis, and descriptive statistics. It is ideal for survey data and structured data sets. Built-in output viewer for easy reporting. Its limitations would be it is less flexible than R or Python for advanced custom analysis. It is expensive, requires a paid license, limited for large-scale data processing and machine learning. So you may choose this if you work in social sciences, need a straightforward tool for statistical analysis without programming, and can handle structured survey or experimental data. Then moving on to R, it is best for advanced statistical analysis, data visualization, or reproducibility. Its strengths are powerful for statistical computing and hypothesis testing. It has a vast library of statistical packages, example ggplot2 for visualization, dplyr for data manipulation. It has an open it is an open source tool, free to use, great for handling structured and unstructured data. Limitations: it requires coding knowledge. It is slower than Python for large data sets and machine learning. Has a less user-friendly interface compared to SPSS or Excel for beginners. So choose R if you need advanced statistical modeling, high quality visualizations, open source, flexibility for research. Then moving on to Python, it is best for data analysis, automation, machine learning, and AI applications. Its strengths are that it is excellent for large-scale data processing, extensive libraries like pandas for data manipulation, matplotlib for visualization, automates data analysis tasks and integrates with other tools. It is open source and is widely used in academia and industry. Its limitations are that it requires coding expertise, not as specialized for statistical testing as SPSS. It can have a learning curve for beginners. So you may choose it if you are working with large data set, need automation, or plan to use machine learning or AI in your research. I would like to talk a little bit about minimizing risk of missing data during data collection process. So a few strategies about that could be designing a clear data collection plan. Before you start, ensure your plan covers all necessary steps, timeframes, and tools. Make sure everyone involved understands the process and their roles. Pilot test: conduct a small scale pilot before full data collection. This can help identify potential issues in your process, like unclear instructions or challenges in tracking data. Use multiple data sources. When possible, use multiple data sources to cross-check information. Ensure that gaps are less likely to occur. This can include combining surveys, interviews, and existing records. Ensure clarity in data entry. If you are using forms or surveys, make sure all your questions are clear and easy to understand. Ambiguity or complex question can lead to participants skipping items. Real-time monitoring. If possible, monitor data collection in real time. This allows you to spot gaps or inconsistencies early and address them before they snowball. Training: make sure all personnel involved in data collection are adequately trained. They should understand the importance of completeness and accuracy in data entry. Plan for follow-up. Build follow-up procedures for missing data, such as contacting participants to request missing responses or addressing issues immediately after collection. Consider imputation techniques. If missing data does occur, explore statistical methods like imputation to handle during analysis. Taking these proactive steps can reduce missing data and ensure more reliable data sets for your research. With that, I'll pass on to Anami.
Thanks, Arpita. I'll now talk about how to present data for quantitative studies. So data can be complex to understand, so it's important that it is presented clearly. There are numerous ways you can present your data, including text, tables, graphics or graphs, figures, equations, and statistics. To use data effectively and trust the results, we need to understand where it came from, how it was defined, and the context in which it was collected, to name a few non-exhaustive points. We have a great webinar that dives into this topic, but we wanted to cover a few highlights today. So if we go to the next slide, please. Here is a clear presentation of descriptive statistics, clear and easy to understand way to present data that isn't complicated as a regression analysis as seen in the next slide. This is a super clear visualization of changes over time across multiple different contexts. In the next slide, please. Over here, we have heat maps are a great way to present data when one is interested in the geographic spread of instruments or variables. It is much easier to see the spread than see it in words. In the next slide, please. This is with an equation, we have to make sure to example the variables. On the next slide, please. This is a standard results table of the OLS analysis for those interested and pro-demarcating the stat significance. This is an example. It also makes clear in the footnote what the asterisk means. In the next slide, please. It's a nice display or illustration of predictive values with confidence intervals. In the next slide, please. I'll now talk about how to present data for qualitative studies. It is important to note that qualitative studies can stand on their own or they can be conducted alongside quantitative methods. This flexibility allows researchers to gain a more comprehensive understanding of a topic by combining numerical data with rich narrative insights. For example, a survey might tell you what is happening, but a qualitative interview can help explain why. Unlike quantitative research, which focuses on measurable data, qualitative research explores more abstract elements like experiences, beliefs, attitudes, and behaviors. These are inherently harder to quantify, but are critical for understanding the deeper context behind what we observe. Because of this, qualitative findings often take the form of themes, narratives, or case examples rather than statistics. Ethical considerations are especially important in qualitative work. Researchers must be diligent about maintaining participant privacy and confidentiality, especially since the data can be quite personal and detailed. This includes anonymizing transcripts, being cautious with direct quotes, and obtaining informed consent for how the data will be shared or published. When presenting your qualitative study, it's crucial to clearly outline your methods. This means describing how participants were selected, how data was collected, whether through interviews, focus groups, or observations, and how the analysis was carried out. Transparency in your approach strengthens the credibility of your research. To guide this process, the correct or consolidated criteria for reporting qualitative research is an excellent tool. It's a 32-item checklist that helps ensure you've thoroughly and transparently reported your methods and findings. Referencing correct in your presentation or publication shows that your study follows the recognized best practices in the field. As such, qualitative data is difficult to present neatly in tables and figures. It is usually expressed in words, and this results in a large quantity of written material through which you must guide your reader. Structuring your analysis well is therefore very important. Try to make your sections and subsections reflect the themes that have emerged from your analysis of the data, and make sure your reader understands how these themes evolved. Headings and subheadings, as well as directions to the reader, are forms of signposting you can use to make these chapters easy to navigate. You can go to the next slide, please. So this article does a great job of thinking about the flow of qualitative research, presenting qualitative data by main themes picked up in interviews and focus groups. This is a nice way to structure qualitative data. The next slide, please. This is a clean way to summarize participants for clarity and transparency. On the next slide, this is a common method of utilizing interview data to embed responses into the text to get the point across. It is useful for clearly showing the point and respecting the words of the participants. The next slide, please. So how to present data? So we have tables and graphs. Tables are the preferred format when presenting data in research documents. The column and row structure allows readers to easily evaluate, compare, or simply understand data. Tables and graphs should carry information that cannot be condensed into a paragraph. A well-constructed table should be self-explanatory and include core main parts like the title, columns, and rows. Graphs allow you to present data visually, emphasizing important points, so you don't need to spend time on lengthy textual explanations. Graphs are particularly good for showing a trend in the data that would not be clear in tables. There are many different types of graphs that can be used to present data. A well-constructed graph should have a title, figure legend, and footnotes along with the figure. The title should be concise but informative. A caption or heading should be given to every graph in the research document that succinctly explains the data. They should appear just above or below the graph. A figure legend can be used to define abbreviations, explain symbols, acknowledge sources, and clarify any aspects of graphs for readers. The legend should ensure the graph is self-explanatory. Footnotes should be included where appropriate, detailing any relevant information. It is important to always remember that clear and consistent labeling should be provided for all important or potentially confusing parts of a graph. I'll now hand it back to Arpita.
Thanks, Harami. Let's talk about a little bit about data sharing and management. Sharing data promotes transparency and enhances collaboration. Use structured formats and document metadata for future reference. Ensure compliance with data sharing policies and obtain necessary permissions. Sharing data appropriately is important to ensure privacy, security, and ethical use. Some guidelines to consider when sharing data. Obtain consent. Ensure that the individuals or organizations whose data you are sharing have consented for it to be shared. It is especially important for personal or sensitive data. Anonymize data. If possible, remove or alter any personally identifiable information to protect the identity of individuals. It is essential in research, healthcare, or any context involving sensitive data. Use secure methods. Share data using secure, encrypted channels. Avoid sending sensitive data through unsecured methods like email or cloud storage without encryption. Limit access. Share data only with people who need it for a specific purpose. Implement access controls to restrict unauthorized access to the data. Follow legal and ethical guidelines. Adhere to local, national, and international laws and regulations such as GDPR or HIPAA, depending on the type of data and jurisdiction. This also includes ensuring that the data is not used for purposes beyond what was agreed upon. Data sharing agreements. Establish clear agreements or contracts that outline how the data will be used, who can access it, and the responsibilities of all the parties involved. Transparency. Be clear about how the data will be used, why it is being shared, and how long it will be retained. Transparency builds trust and ensures compliance with ethical standards. Data provenance. Document the origin and history of the data, especially if it is being used for research or collaborative projects. This helps in tracking the lineage and ensures accountability. Could we move on to the next one, John? Now, coming to AI policy or talking about AI. So while talking about data collection and analysis, I believe it is important to address the growing use of AI in research and academic writing. SAGE recognizes the value of artificial intelligence and its potential to help authors in research and writing process. So I would like to, talk a little bit about SAGE's AI policy. It has been developed to assist authors, reviewers, and editors to make good judgment about the ethical use of such technology, as while AI can be transformative, they are unable to replicate human creative and critical thinking. Could we move to the next slide, Sean? SAGE's AI policy distinguishes between AI tools, assistive AI tools, and generative AI tools. Assistive AI tools make suggestions, corrections, and improvements to the content you have authored yourself. Tools like Google's Gmail or Outlook Word have offered to flags spelling or grammatical errors for years. So these would be assistive use of AI tools, while generative AI are tools such as ChatGPT, which produce content, whether in form of text, images, or translations. So, as per Sage's AI policy, authors are not required to disclose the use of assistive AI tools in their submission, but all content, including AI assisted content, must undergo rigorous human review prior to submission. This is to ensure that the content aligns with our standards for quality and authenticity. Authors must disclose any AI generated content appearing in their work, including text, images, and translations, while submitting it. This will allow the editorial team to make informed publishing decision regarding submission. Uh, Things to consider before using generative AI tools. Any AI generated content should be disclosed at submission. A little bit about LLMs, which are, included in our AI policy. LLMs can sometimes hallucinate, which means producing incorrect or misleading information, especially when used outside their domain of training data or when dealing with complex or ambiguous topics. Hence, when using it to produce any sort of data, one must be careful to ensure the accuracy, validity, and appropriateness of the data. LLMs are trained on text that can include biases, and there is inherent bias in AI tools because of human programming. Thus, AI generated text may reproduce these biases or may overlook perspectives of populations that have been historically marginalized. Relying on LLMs to generate text or images can inadvertently propagate these biases, so you should carefully review all AI generated content and ensure it is inclusive and impartial. And finally, one must never share any sensitive personal or proprietary information on an AI platform like ChatGPT, as they may expose sensitive information or intellectual property to others. Any information that you share with AI tools are collected for business purposes. So that is it about this slide. I'll pass back on to Sean.
I thank you very much, Arpita, for that, and thank you, Anami, for your presentation. With that, I want to pass it over to James to hear his perspective on the topic.
Yes, thank you, Sean. First, I should disclaim I'm not a Sage employee, although I do edit some journals for Sage. But I'm really here in my capacity as a researcher and a little bit as an editor. So when I think about publishing research, especially in terms of data collection and data analysis, uh, so um, I my personal work often involves thinking about emerging technologies and how it relates to research. Um, One of the things that I always think, I've been around for a while, so kind of was, I started grad school when the internet was actually still new. So Google was just a few years old, actually, when I started grad school. And you see cycles of emerging technologies and early adopters always uh, face the same kind of perennial problems. And one of those uh, problems or issues that early adopters need to address is how to future-proof our work. Again, thinking back to internet technologies, I just recently, until I donated some of my books, had a lot of books on chat rooms. Of course, 30 years or so later, that's not relevant. So if we want to future-proof our research, well, one thing that I think is important with regard to data collection and analysis is to as much as possible, try not to be platform specific. Platforms come and go. Even if we think that, oh, of course, this new thing is so innovative, it'll stay around forever. That typically hasn't been the case. And one thing that I think is a way that we can ensure future-proofing our work when a new technology emerges is this. And I'll use a metaphor, and I promise it's apropos of something. Um, so please, if you will, stick with me. So I used to teach cinema, and typically in the history of cinema, we start with the early days of cinema. And I think my students had always been very surprised how different early cinema was. So in the early days of cinema, when cameras were new, uh, people thought, well, okay, well, what should we do with this new technology? And then someone came up with the idea, well, maybe we should film plays. People really love plays. So let's just film plays, and then you can watch a play, wherever and whenever you want. Um, and they thought, well, where should we put the camera? Well, we should put the camera front and center. So that's the best seat in the house. So let's just leave the camera there. And that was the beginning of narrative cinema. So again, if you've watched a film in the last 100 years or so, we know that films don't just have a static camera front and center, nor do we just film plays. Uh, at some point, it occurred to someone, well, we can move the camera around, right? And that opened up a lot of possibilities. So when I think about publishing and methodology, uh, again, with regard to data collection and analysis, any technologies regarding that, what I try to think about is to think through not repeating the film plays kind of approach to the new technology, right? So the question that I ask myself is, well, sure, a new technology can make something that I've always done easier, possibly more efficient. Um, but am I really exploring that new technology? Am I thinking about, well, okay, here's this technology that we haven't had. What can I do with it um, that I haven't been able to do before? And again, as an editor, I really do like to see those kinds of articles. Um, of course, when people are early adopters, we need to consider ethical considerations, like we've been saying during this webinar. Um, and those might not always be fully developed early on, but again, some places to look at are IRBs or ethics review boards, university policies, journal policies. Um, uh, but I think that is, in general, a good question to ask oneself. So complying with all the guidelines that I need to, what does this new technology bring to the table to my research that I haven't been able to do before? And I think that's a good way to future-proof one's research. So again, thank you so much for letting me talk today. It's been a pleasure.
Excellent. Thank you very much, James. We are about to move into our Q&A, but beforehand, I want to just resharing my slides to flag some upcoming webinars. So we have a webinar in a few weeks on June 11th on how to convert a dissertation or thesis into a manuscript. So I'd recommend this to anybody who is a postgrad student, somebody who might be finishing up their thesis at the moment, or potentially to anybody who mentors somebody in that position. And this is a good way to get started. Later in June, we have a Pride Month webinar on research that supports the queer community. And we have other webinars coming up in July and August on article and journal level metrics and how to write a research grant. We've got plenty more coming, so keep an eye on our webpage, which I will send as part of the follow-up. I want to note that we have a dedicated space on our Journal Author Gateway for how to get published resources with guidance. We have translated content into simplified Chinese. Basically, any question you have about the publishing process can be found here. And one thing I want to keep up on our screen is our forthcoming author newsletter. This new campaign will go out quarterly and will include academic publishing resources and also upcoming events pages. So I'll leave this on the screen for you. Feel free to scan it and submit your information if you would like to receive this moving forward. The first newsletter should be going out in June, so definitely keep an eye out for it. And with that, we're going to move into the Q&A portion of today's call. Please continue to send any questions you may have via the Q&A on the bottom of your screen. But first, I would like to ask our panelists the one question that came up a few times that I think is particularly important. How do you make data representative?
I can start us off if you'd like. So in order to make data representative, you need to ensure it accurately reflects the population or phenomenon you're studying. This is critical for drawing valid conclusions and minimizing bias like we've been talking about today. So first, you'll want to define the target population. Really start by clearly specifying who or what you're trying to represent. Is it all adults in a country? Is it children with a specific medical condition, patients at a particular clinic? And once you've done this, use the proper sampling techniques like we talked about. You can use probability sampling, simple random sampling, stratified sampling, cluster sampling. Cluster sampling is randomly selecting entire groups or locations, or systematic sampling. And then you'll want to ensure adequate sample size. Here, you can use power calculations or rules of thumb to ensure your sample is large enough to detect meaningful differences and represent subgroups. As we talked about today, you'll want to address known sources of bias. Selection bias is if certain types of people are more or less likely to be included. Non-response bias, another type of bias, is if those people who don't participate are systematically different. Attrition bias is if participants drop out in ways that affect the results. So thinking about your data and what data you actually collected and what biases might be there. You can apply weighting if needed. If your sample ends up over or underrepresenting certain groups, you'll want to use statistical weights to adjust your data. This is common in survey research and large national data sets. Be sure to track your demographics or key characteristics in real time and adjust recruitment strategies to fill in gaps. So, for instance, you might want to do more outreach in underrepresented regions or areas. You'll also want to validate against external benchmarks. So compare your sample's characteristics with known data like consensus or registries, and this will help confirm representativeness or justify weights. There was a question that came up that I wanted to address if you don't know the population size. If you don't know the population size, you can still determine an appropriate sample size using standard formulas and assumptions. This is quite common in exploratory research or large or underdefined populations like internet users and qualitative studies. If the population is large or unknown, sample size calculations assume an infinite population, which simplifies the formula and is statistically conservative or safer. For quantitative studies, like means or comparisons, if you're running t-tests or you don't know the n, you can base your sample on effect size, alpha, and power. You could use a software like G-Power. And then for qualitative studies, the population size is not often as relevant. You'll want to aim for thematic saturation, not necessarily statistical generalizability. So for qualitative studies, you may only need 10 to 20 interviews, maybe 3 to 6 focus groups, or 1 to 5 cases. You can really think about when are you not getting any more new information, that saturation. And if the population size is unknown, you can assume that it's large. You can use standard sample size formulas or software, use effect size and power for hypothesis-driven designs. And in qualitative work, you can rely on data saturation work, not size formulas like we just talked about. James or anyone else from the group, I don't know if you want to add in anything to this question on how we make data representative.
It seems like you covered it perfectly. Thank you very much, Jessica. Um, we've got another question in the chat that I think is pretty great. How do we decide sample size when using a simple random sampling or by any other methods?
I can jump in on this one as well. Um, Deciding the sample size is a crucial step in study design, just like we've been talking about here. So whether you're using simple random sampling or another method, the core principles of sample size determination remain the same. There's a couple key factors that determine sample size. So population size, or N, is the total number of people or units in your target population. The margin of error is how much error you can tolerate, often 5%. Then there's the confidence level. That's how sure you want to be. This is usually 95 to 99%. The standard deviation is the estimated variability in your data. If unknown, use 0.5. That's the worst case for proportions. The effect size for hypothesis testing is the minimum difference you want to detect. The power of probability of detecting a true effect, most often this is 80 or 90%. You might be asking, what tools can you help with this? What tools can you use to help with this, especially if math isn't your favorite part? There's Qualtrics or Survey Monkey calculators. I mentioned G-star power for hypothesis testing. We talked about R or Python for custom power analyses. A couple things to note, like we've been talking about today. If you're using simple random sampling, ensure you're using true randomness. If you're using cluster sampling, that often increases the required samples, so think about broadening that. We suggest avoiding convenience sampling. And then think about your resources and budgeting. Can you afford your ideal sample size? Do you have the resources and budget and the funding to conduct this research? Once you've conducted your data, especially if you're getting different types of responses, look at your response rate. If it's only at 50%, you might want to double your recruitment to get a better sample size. And avoid oversampling unnecessarily, especially in vulnerable populations. James or anyone else, anything to add on deciding sample size?
I can jump in from a qualitative side since that's really where I work. So it can often be the case that qualitative work has smaller n. One methodology that I think about is qualitative comparative analysis. The claim is that we can do something with something as small as n equals 6. Um, that's a methodology if you're interested. The thing to note, though, is that we don't claim statistical generalizability from small n. In fact, qualitative comparative analysis, Charles Reagan is the name that I associate with that. It doesn't even use statistics. It uses a different form of math, set theory. There are, if you have, as you were saying, Jessica, with vulnerable populations, maybe you don't have access to large N, that you can use other methods that they do exist.
In our last few minutes, I've got another question. How many participants are enough to meet validity standards in a study intended as a smaller group?
I can start us out if you'd like, and then maybe James, if you have anything to add. So when it comes to smaller groups, it really depends on the study's purpose, designs, and the type of validity you're aiming to achieve. Statistical, internal, external, or construct validity. first, let's define what a small group means. Is it a pilot study? Pilot studies will often be 10 to 30 participants. James, maybe you can speak better to this, but a qualitative study is often 5 to 30 participants per group until saturation. For small scale quantitative studies, the minimum depends on the expected effect size and desired power. For a quantitative study to meet statistic validity, you generally need a power of 0.8 and an alpha of 0.05. The recommended N for is 30 or more for a medium effect size using t-test. Small effect is usually 200 or more participants. Medium effect is usually 60 to 100 participants, and large effect is 30 to 50 participants. For qualitative studies, interviews, focus groups, as we've been talking about, you're aiming for depth and not necessarily quantity, although those two can sometimes go hand in hand, but a lot of times sample sizes are smaller. In-depth interviews are typically 10 to 20 until saturation, and focus groups will consist of 3 to 6 groups of 6 to 8 people, and case studies are usually 1 to 5 cases. But again, it's defining what does that small group mean for you and what you're trying to achieve, the study's purpose, design, and the type of validity. James, anything worth adding, especially from a qualitative perspective?
Oh, that was excellent. But yeah, I think yeah, validity is a question that we often, from a qualitative perspective, have to address. And I think actually that's an area that we kind of thought we put to bed, but I think maybe we should start revisiting that. So that's the only thing that I'd add is that I think more work can be done on the qualitative side, thinking through validity.
Great. Thank you both so much. And with that, I think it's time to wrap up today's webinar. I want to thank you all for joining. Note that anybody who's attending today live, you'll receive a certificate of attendance, you'll receive a recording, you'll receive the slides. As well, we are selecting one random winner from today's call who will receive free language editing from Sage Author Services. So we will follow up directly with you via email. Again, huge thank you to our speakers, to Anami, to Arpita, to James, to Jessica. We really appreciate your insights, and thank you so much to our audience. We hope to see you in a future webinar. And in the meantime, please take care.